Have you ever wondered what that gray core inside your pencil really is? Most people think it's lead, but that's a common misconception. What's actually inside is a fascinating material called graphite, a substance that goes way beyond writing. It plays a big role in science, industry, and even the future of human technology. Graphite is one of the pure forms of carbon, yes, the same element that forms the basis of all life on Earth. What's fascinating is how the same carbon can take on very different forms. For example, diamond is the hardest known natural material and is made entirely of carbon. Graphite, on the other hand, is also made of carbon, but its atomic structure is completely different. In graphite, carbon atoms are arranged in flat, hexagonal layers, like sheets of honeycomb stacked loosely on top of one another. These layers can slide over each other easily, which is why graphite feels soft and leaves marks on paper, exactly what you experience when using a pencil. But what's even more surprising is that graphite is also an excellent conductor of electricity, unlike diamond, which doesn't conduct at all. That makes graphite extremely valuable for modern industries. But graphite's use goes far beyond pencils. It plays a critical role in lithium-ion batteries, the kind found in smartphones, laptops, and electric vehicles like Tesla's. In these batteries, graphite is used as the anode, helping store and release energy efficiently. Without graphite, those batteries wouldn't work. And now, as the world shifts toward clean energy and electric transport, demand for graphite is rising rapidly. Graphite is also essential in industrial electrodes, particularly in steel and aluminum production. And thanks to its slick layered structure, it's used as a lubricant in heavy machinery. The way its layers slide past one another makes it perfect for reducing friction in moving parts. But that's not all. One of the most exciting discoveries in modern science came when researchers isolated a single layer of graphite, something called graphene. Graphene is just one atom thick, yet it's 100 times stronger than steel, incredibly flexible, transparent, and one of the best conductors of electricity ever discovered. Scientists say it could revolutionize everything from foldable screens and water filtration systems to supercomputers and even smart medical implants. Interestingly, graphite exists in two main forms, natural and synthetic. Natural graphite is mined from the earth, often in countries like China, India, and Brazil. Synthetic graphite is made in laboratories by heating petroleum coke to extreme temperatures. It has a higher purity and is preferred in precise industrial applications, especially in electronics and battery manufacturing. You might be surprised to learn that graphite is even used in space technology. Because of its heat resistance and conductivity, it's used in rocket engine nozzles and other high-temperature components. So yes, the same material in your pencil is also helping rockets fly into space. Another curious thing is that graphite is non-metallic, but conducts electricity like a metal. This property allows it to replace heavier, more expensive metals in many electrical systems, not just in high-tech devices, but even in household tools, fans, and motors. Graphite is also starting to show up in printed circuit boards, PCBs. Some tech companies are experimenting with replacing copper and gold in circuit lines with graphite or graphene, which could make electronics cheaper, lighter, and more efficient. In the world of nuclear energy, graphite is used as a neutron moderator in certain types of reactors. Its ability to slow down neutrons safely and resist extreme temperatures makes it valuable in controlled nuclear reactions, a powerful but delicate use of this silent hero. And perhaps the most important role graphite might play in the future is in energy storage. As we generate more renewable energy from solar and wind, we need better ways to store it. Batteries are key, and graphite, once again, is right at the core. Some experts even say graphite could become the new oil, a critical natural resource powering the 21st century energy revolution. Countries around the world are investing heavily in graphite mines and processing facilities to meet this rising demand. China is the world's top producer, but other nations like the US, Canada, and Australia are expanding their graphite industries to reduce dependency and meet the growing global need. From an environmental standpoint, graphite is also relatively clean and low impact compared to other materials. It requires less energy to process and creates less toxic waste, especially when sourced responsibly or manufactured efficiently. Synthetic graphite, while more energy-intensive to make, is being improved with greener technologies. So in the end, graphite might just be one of the most overlooked heroes of modern science and industry. A material that started in our school pencils is now helping drive our cars, power our devices, and maybe even save the planet. Next time you write with a pencil, remember, you're holding one of the most amazing materials on Earth. If you enjoyed this video, don't forget to like, subscribe, and tell me in the comments which use of graphite surprised you the most. And if you want a deep dive into graphene, just comment. Do one on graphene too.